Dear students, welcome to course on statistical methods for psychological research part 2. In this lesson, we are going to learn determining a formula for t distribution. What are you going to learn in this lesson? Let us look at the learning objectives. Learning objectives are: after completing this session, the students will be able to understand the concept of t distribution and its assumptions and properties, understand the conditions for the applicability of t distribution, define and determine the t statistics by explaining mean, variance and standard error. Let us start. We begin with the first part of the lesson, in which you will learn the assumptions and properties of t distribution. T distribution, it is characterized by its degrees of freedom parameter gamma, which determines the shape of the distribution. Students' t distribution is named in the honor of William Seeley Gosset 1876 to 1937, who first determined it in 1908. Gosset was one of the finest Oxford graduates in the chemistry and mathematics of his generation. T distribution, also known as the students' t distribution, is a probability distribution used to estimate the parameters of population when the sample size is small or when the population standard deviation is unknown. It is characterized by its degrees of freedom parameter. It is denoted as a gamma, which determines the shape of the distribution. Definition of the t distribution: the distribution of the ratio of a standard normal random variable and the square root of a scaled chi-square random variable is called the t distribution. The t distribution is a symmetric and bell shaped. It is similar to the normal distribution, but has a heavier tails, which allows for the better estimation when working with a small sample size. It is related to the sample size used to estimate the population mean. The larger the sample size, the closer to the t distribution resembles a standard normal distribution. As the degrees of freedom increases, the t distribution approaches the standard normal distribution. The t distribution has a mean of 0 like the standard normal distribution, and its shape is symmetric around 0. However, its variance is larger than that of the standard normal distribution, leading to fatter tails. The t distribution converges to the standard normal distribution as the sample size increases. Mean and variance: the mean of the t distribution is 0 when the degrees of freedom parameter gamma is greater than 1. The mean is unidentified for gamma values less than or equal to 1. The variance of the t distribution for gamma is greater than 2 and undefined otherwise. Relationship with the normal distribution: as the degrees of freedom parameter gamma increases, the t distribution approaches the standard normal distribution. When gamma is sufficiently large, typically greater than 30, the t distribution is nearly indistinguishable from the standard normal distribution. Confidence interval: the t distribution is commonly used to construct the confidence intervals for population means. The width of the confidence interval depends on the desired level of confidence and the sample size. A larger sample size or higher degrees of freedom results in narrower confidence intervals. It is important to note that there are also one-sided and two-sided t distributions depending on the specific hypothesis being tested or the confidence interval being constructed. The formulas and calculations for these distributions may differ slightly. The students' t distribution with k degrees of freedom, abbreviated t of k, as the probability density function is given below. F of x equal to gamma of k plus 1 by 2 divided by square root of pi k gamma of k by 2 into 1 plus x square by k whole power minus k plus 1 by 2, where gamma of k is the gamma function. Key statistical properties of the t distributions are listed below, that is, mean equal to 0 for k greater than 0, median is equal to 0, mode is equal to 0, and range is lies between minus into plus infinitive. Then variance is equal to k by k minus 2 for k greater than 0, skewness is equal to 0 for k greater than 3, and kurtosis it is equal to 6 by k minus 4 for k greater than 4. The overall shape of the probability density function of the t distribution resembles the bell shape of the normally distributed random variable with mean of 0 and variance of 1, except that it is a bit lower and wider. As the number of degrees of freedom grows, the t distribution approaches the standard normal distribution, and in fact the approximation is quite close for k greater than or equal to 30. If you look at this figure, if degrees of freedom is equal to 1, we have this curve in the blue color, and if you have a degrees of freedom equal to 5, we have another curve in the red color, and if you have a degrees of freedom equal to 10, we have another curve. Like that, if you increase the degrees of freedom up to 30 and more, we have a standard normal curve is a final one. Assumptions. Random sampling. The observations in the sample should be obtained through a random sampling process. This assumes that each observation is independent and representative of the population being studied. Normality. The t distribution assumes that the population from which the sample is drawn follows a normal distribution. This assumption is important because the t distribution relies on the normality assumption to accurately estimate population parameters. Then skewness and kurtosis. If you look at this figure, the first curve is an example for positively skewed distribution. The second curve it is an example for negatively skewed distribution. The third curve represents 3 types of kurtosis, that is first one leptokurtic, mesokurtic and platykurtic. So, we conclude normally distributed data has no skew, normally distributed data has kurtosis of approximately is equal to 3.0. Independence. It is assumed that the observations in the sample are independent. In other words, we can say the value of one observation does not influence the value of the another observation in the sample. Another property is homogeneity of variance. When performing certain types of hypothesis tests such as a t-test for comparing means, it is assumed that the variances of the populations being compared are equal. This assumption is known as homogeneity of variance. If you look at this figure, we are having homogeneous population and heterogeneous population. How we can collect the sample from homogeneous population and heterogeneous population, we can see now. Suppose we have a homogeneous population, we can select one sample, and suppose we have a heterogeneous population, we can select 2 samples, unanimized from one sample from unanimized and other sample from management. So, finally, we have 2 separate samples from heterogeneous population. It is important to note that these assumptions are not strictly required for the t distribution to be used. Assessing the validity of these assumptions before applying the t distribution is crucial. Graphical methods, for example histograms, normal probability plots or formal tests, for example Shapiro-Wilk test for normality, can be used to assess the normality of the assumption. Additionally, subject matter knowledge and understanding of the data collection process can help evaluate other assumptions. If you look at the image, Kolmogorov-Smirnov test, Shapiro-Wilk test, Anderson-Darling test, these 3 tests are used to finding the normality of data. Then and also here we are giving corresponding statistics and p values are given in this image. If the p value smaller than 0.05, if it is yes, then normal distribution is not assumed. If it is no, the normal distribution is assumed. Properties. Symmetry. There are several properties. The first property is symmetry properties. Like the standard normal distribution, the t distribution is symmetric around its mean of 0. The symmetry allows for the calculation of probabilities on both sides of the mean. Heavier tails. This is another property. The t distribution has a heavier tails compared to the standard normal distribution. This means that extreme values are more likely to occur in the t distribution, particularly when the sample size is small. The heavier tails account for the increased uncertainty associated with estimating population parameters from smaller samples. Degrees of freedom is another property, important property. The shape of the t distribution is determined by its degrees of freedom. The degrees of freedom represent the number of independent pieces of information used to estimate a parameter. As the degrees of freedom increases, the d distribution becomes similar to the standard normal distribution in shape and has narrower tails. Central limit theorem. The t distribution becomes increasingly similar to the standard normal distribution as the sample size increases. This convergence is due to the central limit theorem, which states that the distribution of sample means approaches a normal distribution as the sample size grows larger. Hypothesis testing. The t distribution is commonly used for hypothesis testing, particularly when working with a small sample size or when the population standard deviation is unknown. It provides critical values that enable the comparison of sample statistics to hypothesized values, allowing for inference about population parameters. Confidence intervals. The t distribution is also employed in constructing confidence intervals for population parameters such as mean. The confidence intervals provide a range of values within which the population parameter will likely fall. The t distribution helps determine the margin of error or uncertainty associated with estimate. Non-negative property. The t distribution is non-negative and bounded with the values ranging from 0 to positive infinitive. This property ensured that probabilities calculated using the t distribution are within a meaningful range. Dear students, I hope you understood all the concepts. We will continue in the next video. Thank you.